So I've titled this talk Think First, Spray Later. So trying to go through some fungicide things and really going to look at two diseases. Going to look at stripe rust and also yellow spot and try to get across why we don't get the same job out of our fungicides against both of those two diseases. So we've become very adept at controlling stripe rust and getting good control out of fungicides over the last couple of years, but we try to move that across to yellow spot, we're not getting the same results, and there's reasons why that's happening. So very quickly, I think the key things with our rust, they're crop specific, so the ones we get on the wheat only affect the wheat. But in pathology terms, they're what we call a biotroph. And what we mean by that is they feed on living cells. So they're not trying to kill the plant, they need a green living plant to survive over that summer and also to feed on during the season. So the reason why that's important, when you actually apply a fungicide, because the disease is not trying to kill those cells, you get full movement of that product if you get contact through the leaves. You actually strip the infection right out with stripe rust. So you basically, if you get coverage, you eliminate it from your paddock, you've got to get infected from outside again. So that's what happens with the rust. We should be pretty good at identifying rust by now. Everyone's seen it, so the clean hanky is still the best way. Definitely clean, or you could spend a lot of money unnecessarily. Wipe that down the leaf, the pustules come off and you can see it. Some work we've done over the last couple of seasons is really trying to figure out which is the money spray. We know the fungicides are important, but it's all about protecting those top three leaves, so the flag leaf and the two leaves below. And what we found, I guess, this is 2011, quite conducive year to stripe rust, moderately susceptible variety Ellison. And what we find that in high stripe rust pressure sites, so this is basically was east of the highway, some more frequent rainfall, high yields, so we're up around that 5-6 tonne in 2011. We basically get about a 50% benefit from putting fungicides on in a moderately susceptible variety when we do a spray at 32 and then followed up at 39. So that spray at growth stage 32 or second node is when that third leaf down, flag -2 is fully emerged, you protect that, and then your next one is time to cover your flag leaf. So you can take that right out. What we find too, if you just do one spray bud, if you did a 32 only, it's basically doing about 50% of the job under high pressure, and you need that follow-up 39 spray to get that full control. Where we found it was quite different is when we moved west of the highway into more moderate disease pressure. Lower yield potential, so in 2011 we're up around that 3.5, 4 tonne maybe. And really find the big difference here is that one-off 32 spray. So if there's a money spray for us, under those conditions, it's that one-off 32. It's doing 80% of the effect of a 32 plus a 39. Because we're pushing through into heading quicker out in that environment. And if we delay it just to a 39, we lose too much of our two leaves below that in our environment. And this is really sort of information we've got out there, because when you look down south, a lot of the early advice was just, if you're going to do one spray, do it at 39. We found out that just didn't work for us in the north pretty quickly. But the key thing out of it is fungicides are very effective at controlling stripe rust. Okay, and we've got that come through. Even in moderately susceptible varieties, 2 well-timed sprays to protect those top 3 leaves, and we can pretty much eliminate all the yield loss from stripe rust. But do we need to spray all varieties? Okay, so we've done 26 trials over 2 years now. This is from Gilganda 2012. So this had 13 sites this year. This was the only one that really developed significant levels of rust this year. Looking at moderately susceptible varieties this way and moderate resistant this way. Comparing full control, so that was a flutriafol on the starter fertiliser or impactor intake in furrow, and then we put a folicure on at growth stage 32 and again at 39. So you've had 3 fungicide inputs. Full disease control versus the red bars, doing nothing, just let the stripe rust run in those varieties. As you can see, you're only getting a yield benefit from controlling the stripe rust when you're in moderately susceptible varieties, so between 12 and up to 20% in this trial in 2012. So the key thing here is, even with 3 fungicide inputs, we can't get a yield benefit out of spraying moderate-resistant varieties. Okay, and we're up to 26 replicated trials now through central New South Wales up into northern New South Wales. High, low disease pressure, high and low yield, and you just don't get an economic benefit out of spraying MR varieties. Okay, genetics is free, so if you're growing those moderate-resistant varieties or better, they'll take care of the disease and there's no cost. So we often hear it said, spray them anyway, you'll stop the plant fighting the disease, you'll take it out with a fungicide and you'll get your return on investment. It just doesn't happen. The cost of the plant fighting it is so minimal that you won't see that come through. Paul touched on this in his last one too. There is big issues out there. So when you start doing wheat, we've done some stuff with the University of Southern Queensland with a molecular test as well. There's big issues with seed purity, and that really complicates when those contaminants in there are quite susceptible to rust. So there was actually a Gregory crop down around Coolah last year, which probably benefited from a fungicide spray. Okay, and when we went and explored that, it wasn't the Gregory plants that were taking it. There was Ventura contaminants in there, and they were taking the rust very badly. Okay, and that's issues in there. But if it's a seed contamination issue, you've got a clear distribution with stripe rust. You'll have individual scattered plants across the paddock taking a lot of rust if they're a more susceptible variety that's contaminating, and the ones around it will generally be clean. There's no reason those ones around it wouldn't be getting infected as well. They still had spores land on them. They just didn't develop rust because they were the right variety and they were moderately resistant. Okay, here's one that's caused us a fair bit of grief over the last couple of seasons. So, going into wheat-on-wheat situations, you've got stubble down the base, seen a lot of this lower leaf and sometimes a lot of this leaf going yellow and tiny little spots on it. So this is actually yellow spot. Jump into the chase. If you don't want to see this, don't sow wheat-on-wheat. Okay, it is a wheat-on-wheat problem. And it's where we're growing susceptible varieties back on their own stubble, so growing Gregory on Gregory, or Spitfire on Gregory, or Spitfire on Spitfire, that we're having this problem early on. Usually it doesn't come to much, but certainly there has been seasons. But we all get alarmed when we see this early in crops. Okay, we don't like to do it, but certainly burning is effective at getting rid of that stubble, which hosts the yellow spot fungus, and reduces that inoculum, and you won't have a problem. We heard a lot of reasons this morning with sulphur and other things why we don't want to burn stubble. Obviously, you can move to more resistant varieties. So there is varieties out there that have got better resistance to yellow spot. Unfortunately, when you look at a lot of those, they're actually not very good for another one of our main problems, Pradolenchus thornii. They tend to have poorer tolerance there, so there could be issues there. Okay, but there certainly is some growers keep a variety such as Crusader in their system for one reason. That's what they put on their wheat-on-wheat paddocks. They know they won't have to worry about yellow spot. They can spray the stripe rust with the fungicides, but they've learnt that they can't control the yellow spot with fungicides, so that's why they make that conscious decision. The key thing is, fungicides are a very poor last resort against yellow spot. Okay, they don't do the same job, and we'll go through why that's the case. Okay, so the key thing here, we talked about rust. It was a biotroph. If you learn nothing out of this one today, yellow spot is what we call a necrotroph. What that means, it actually kills the cells and it is feeding off dead cells. And how that does that is actually how the disease got its name. Okay, so it's killing the cells by producing a toxin. The yellowing you're seeing here around the edge of the lesions is that toxin production killing off cells. It kills the cells and the fungus comes in and feeds in behind that. So you've got a clear pattern as they elongate. These have been killed off, they dry off and just become that what's called tan lesion, just dried up dead cells. Produce toxin just around the edge, kill off the next lot of cells, and that's where the fungus feeds next. The key thing with this is it doesn't produce a mass amount of toxin and go and kill the whole leaf at once. So it doesn't want to produce toxin, translocate it through the leaf and kill all those cells. Because then that'd open it up to colonisation by other saprophytes, other fungi. So it's evolved to only want to produce that right in advance of where it's going, and that's what gives it its clear symptoms. Okay, it is a wheat-on-wheat disease. It's got various names. We've got a bit of a push, probably we should be calling it tan spot. The issues that's happened the last couple of seasons is we've all got focused on this word here in the name. We don't even worry whether there's a spot half the time. As long as it's yellow, we assume it's yellow spot and we chuck a fungicide on. Okay, it was undoubtedly from the stuff that we saw, it was the most misdiagnosed disease in 2012. Okay, we had transient waterlogging early on, nitrogen deficiency, people thought that was yellow spot. I know fungicides went out. We had herbicide phytotoxicity around frost events. That got called yellow spot in certain situations, fungicides were put out. And we read in the Queensland Country Life that they actually got some frost during heading up there. People assumed it must be yellow spot, we might as well chuck a fungicide on for that as well. Okay? Fungicides will fix nitrogen deficiency, transient nitrogen deficiency with waterlogging, if you get about 3 or 4 weeks of dry weather after it. That's tongue in cheek. No, Mal. Okay, so how does it actually work? So it's surviving as the pseudothecia on the stubble, so it's a wheat-on-wheat situation. these are full of these little ascospores. They basically get wet, swell up and expel the ascospores under pressure, but they only go about 10 centimetres up in the canopy. So they're creating lesions low down the canopies, which is what you're seeing. If you get continuing weather, you get a second spore structure called a conidia formed, and they can go a bit further distance, up to 100 metres. Okay, so they're being formed on the old leaf lesions. So it's got a wide temperature range, 20 to 28. You only need 6 hours of free moisture, so it doesn't have to be rain, dews will do it too. Free moisture, and you get the ascospores and the conidia can infect. Quite a short cycle time, 4 to 7 days, so probably half or a bit less than that than you see with stripe rust. So it can strip leaf off you quickly if you run into conducive conditions, which is what we see. But you really need those repeated rain events to drive it from the lower canopy into that upper canopy. So it's a disease of very wet years. 1998, 2010 is when it's really moved up the canopy and caused us issues. So what happens, we've got it in there early, we're going across the paddock with an in-crop herbicide. At mid-tillering, we want to put a fungicide in and try and control our yellow spot. Okay, why is that not working so well? Basically, all the fungicides, they only protect the leaves that are out. So they can only move one way in the leaf. Where they hit the leaf, they move in the xylem, which is the water flow, they move from where they hit to the tip. It can't go back the other way because the water doesn't flow that way. Okay, so when you put them on at mid-tillering, the new leaves that come out after that haven't been hit with a fungicide and they're unprotected. And when you're spraying at mid-tillering, those top 3 leaves, the flag -1, flag -2, aren't out, so they're not protected by fungicides. So they're still vulnerable later on. So you really, those early sprays are all about maybe an inoculum reduction is what you're doing those for, and a bit of crop health to get you through that stage. The other thing that happens, but is you actually get infected off that stubble. So if you've got those fruiting structures, the pseudothecia and the stubble, they can infect you through the whole season. So I think it was Bob Rees and Greg Platts did some work in Queensland, showed that they basically released ascospores from March right through October. This was back in the 90s. And there's some stuff out of Canada we got hold of as well. Just showing here, even at early leaf stages, this is the maturing pseudothecia, so the release of ascospores of the stubble. It's happening right from these stages right through to heading across 2 years. So that stubble is an inoculum source throughout the whole season. So if you spray it mid-tillering, you still can get infected. Those new leaves can get infected off that stubble if you get rain events. And we saw very different perceptions of how good those early sprays for yellow spot were last year. So guys up around Moorhoo who got a bit of rain after they put their mid-tillering spray on found that those new leaves got infected pretty quickly and weren't that happy with fungicides. Other guys that got about 3 or 4 weeks of dry weather after they did their mid-tillering sprays thought the fungicides were magic. Again, Mel, there was no rain. So why are fungicides in general just not as good on yellow spot? Okay, we haven't got those upfront controls with yellow spot. They work well on rust, your flutriafol, the intake in furrow, the jockey on seed, they're rust products. They don't work against yellow spot. There's plenty of data on that, and we got stuff last year as well. The other thing is all the products lack curative activity, and I'll put some data here out of Germany in a sec. So they can't actually clean out an infection once it's established. They've got very poor curative activity. So you're really looking at a range of fungicides, and all the new ones are the same. You're really relying on just protecting activity. So it's very much like an ascochyta situation. And basically the other thing is you can't get a fungicide into dead tissue. So that tan lesion, the tan spot, as we said, was killed off by toxin, by the yellow spot fungus, it becomes dead tissue. You can't move a fungicide into dead tissue. There's no mechanism for it to get in there. So you never kill it. So what will happen when you spray those mid-tillings, you'll stop those lesions elongating. You will reduce conidia production on the old lesions, but you won't eliminate it. The second that wears off, after 2-3 weeks, the product wears off in the leaf, the show's back on. You get reinfected back off the stubble, you get reinfected off those lesions. So it bounces back very quickly and strips leaf area off you. So it's very hard to control. And certainly protective properties of some of these fungicides vary against yellow spot as well. So this is some data that Nick Poole was fortunate enough to get out of Germany, some detailed glasshouse work. Looking here, so what we're looking at here is tan spot on this side. This is a different disease, Septoria, so concentrate over here. Okay, there's a whole range of fungicides down here which have been blanked out. I just happen to know that this is propiconazole at the full rate, this is at the half rate, tebuconazole at the full rate, half rate, and then we'll stay down here. What we're looking at here is the curative activity in days. The 10-day line is here. So this is the ability, once the fungus is infected and started its infection process, how far that can go before you can still strip it out with a fungicide. You can see here, all of them, if you're really optimistic, they've got maybe 1-2 days curative activity. So they've got very poor curative activity against tan spot. So when do you reckon we should be, if we're going to try and control tan spot with a fungicide, when do you reckon we should be doing it in terms of relationship to rainfall events? Should we go in before a rainfall event, or should we wait a couple of days afterwards? Well done, Mel. I got you to sit up the front for a reason. So yeah, but I don't know, is that what people have been doing, or we're just been, whenever we can get on, we chuck them on and wonder why we're not getting such good control? And certainly you can get, decent protections. You're getting up to 15 days out of both these products, and Amistar certainly is better. Okay, one of the catches, but with Amistar is we can only get it as Amistar Extra, so we've got that ciproconazole component in it. I actually know this line here is actually the ciproconazole. So it was never, ciproconazole was always a rapid rust clean-out product. It was there to rapidly move through the leaf quickly and there to strip out the rust, stripe rust. So it's not surprising it doesn't have strong activity against yellow spot. Okay, so hopefully you're a bit less excited about fungicides. But one of the key things, as I said, it was the most misdiagnosed disease. So these are all samples that were sent in to us over at Tamworth. We run a free diagnostic service there. Samples sent in where people wanted to know whether they should be putting a fungicide on. They thought they had yellow spot. So just general yellowing here, things more classic. So what we can do as pathologists, and certainly the Queensland group can do it too, is once you get a sample in, you cut off symptomatic bits, what people think is yellow spot. We put it in Petri dishes under alternating UV light. We basically force the fungus to sporulate within 48 hours, produce the conidia. It's quite distinctive, and you get a definitive diagnosis whether it is or isn't really yellow spot. A bit harder to do in the paddock. But first of all, you can tick some boxes in the paddock. So if you think you've got yellow spot, if you've been told you've got yellow spot, there's got to be a few key things that are pretty obvious if you're on the right track. So first of all, you've got to see wheat stubble in the paddock. You've got to be in a wheat on wheat situation. So if you're wheat on barley, not an issue. Or barley on wheat, it doesn't jump across. Okay, so you're in a wheat on wheat situation. The other thing is you need to see those black fruiting structures, those pseudothecia are visible on the stubble. They're quite characteristic here. You actually rub your finger across them, they're a little bit abrasive, they've got microscopic spines on the end, and that's what you're knocking off as you rub them. And even at low levels you can still sit in here. Okay, so if you've been advised that you've got yellow spot, and you basically haven't got any wheat stubble, and you haven't got any black fruiting structures on the stubble, then you can probably guess where the diagnosis was pulled from. I've been waiting. I've given this talk, this is the 6th time now, I've been dying to see it on the big screen. We'll just go back quickly. Okay. The other thing is those symptoms are very characteristic, okay? We think of what it is. Remember, a necrotroph. It is producing toxin, that's how it's killing the cells to feed. So you've got toxin production, the yellowing, and cells dying in behind it. Even as they get bigger, still toxin production just in front of where it is, the yellowing, dying in behind. These are older lesions, so they're elongated. Still a heap of dead tissue here, toxin production just immediately around that, which is the yellowing, and then it's killing them in behind there. So very clear characteristic symptoms. You don't get general yellowing. Okay, so do the spots look right? This is yellow spot in here to keep your eye on. This is things that were sent into us. So just general yellowing of the leaf here, concentrating a bit towards the tip. This one here, big white blotches on the leaf. That was actually gramoxone damage, but they wanted to spray a fungicide for yellow spot. And just this general sort of browning, and this can get a bit hard, and this is why you test them, but just that general, which we think was more probably related to herbicide phytotoxicity. The other thing is that there'll be a clear distribution on the leaves with yellow spot or tan spot. Okay, so don't try to look at a whole plant. I pull an individual infected tiller off. It's a lot easier to look at just one tiller than try to track it. You can track the leaves in. So with tan spot, the lowest leaf will always have more lesions, and generally they'll be bigger. Got infected, they've had longer to elongate. The next leaf up will have fewer, and a few again on the next one up there. So something like this just isn't characteristic. It's really concentrated on that not the bottom leaf, but the next leaf up, and it was running towards the tip. So this was more around, I think, an issue around a spray event and a frost timing when that went on. The other thing is on that individual leaf, it's quite characteristic. So with yellow spot, it's just spores, whether it be ascospores or conidia, randomly landing on a leaf. They get their moisture requirement, they infect, and you get your lesions. So it tends to be generally random across the leaf. Certainly not concentrating towards a leaf tip. So this yellowing run up here. This is more something that's going in the xylem flow and becoming toxic up there. And we heard a fair bit of stuff this morning about what can do that. The other one we've seen this in Gregory and other varieties too over the last couple of years. People have been concerned that this is yellow spot or some expression of stripe rust. This leaf tipping in Gregory. Okay, it's actually related to a particular combination of genes, a leaf rust gene, LR34, when it's in combination with YRE18. It is just genetic. You don't need to spray fungicides on something like this. It's not a disease. Okay, the wash-up. We call it yellow spot in Australia. I think we've been misled the last couple of years by the word yellow. It's called tan spot everywhere else, so if we can start calling it tan spot, I'd be happy. Others will get confused. Does not cause general yellowing of leaves. Okay, remember it's that toxin production. The yellow is just around where the fungus is killing cells and feeding next. What does cause more general yellowing? Certainly herbicide phytotoxicity. We saw a fair bit of that. We're getting some pretty good tank mixes out there now. And interaction with frost. I look at some of the things, like we want to go across a paddock once and put as much as we can. It's like, you haven't been to the doctor for 15 years and you get all your booster shots at once. He pulls out a big horse syringe and says, bend over. I won't go back to the photo. But, you'd lose a little bit of colour yourself. The other one, nitrogen deficiency. We went up with a heap of low-protein wheat. The signs were there early on. We had a lot of yellow in that lower canopy early on as well. And certainly interaction early on, we had a lot of, a fair bit of waterlogging around, and that'll give you transient nutrient deficiencies as well. Okay, last photo. So this is a photo out of Western Australia, yellow spot over there. Certainly you can see the classic ones here, tan lesions, yellow margin where the toxin's being produced. Then you've got this general yellowing, and some of these over here, the lower leaves going yellowing. Okay, and some of the work you'll see over there, they've done a fair bit of fungicide stuff. They tend to get a lot better activity out of their fungicides when they put some nitrogen on at the same time. Okay, they didn't have the key treatment of just putting nitrogen on, but how much of this is just cleaning up nitrogen and how much is actually controlling yellow spot. Fungicides are not cheap insurance. We hear this all the time. I heard every reason to spray fungicides last year, except that I had a disease that actually could control the fungicide. I was at the critical growth stage. I didn't hear that a lot. We hear this a lot, it's cheap insurance. Okay, we're running over the paddock, it's cheap, we'll chuck it in. I think if you certainly heard a talk there in one of the concurrents, it's a real warning. I think we're heading towards expensive insurance. We will end up getting fungicide resistance in some of our fungal populations. Might take us 10, 15, 20 years, but we're going to lose those cheap triazoles. We've already lost in WA, powdery mildew, we've lost the cheap triazoles over there. They've got to go to more expensive products. Doesn't seem to be that there was any indication that the rust themselves will fall over. There's no evidence of that globally, fungicide resistance to the rust, but certainly yellow spot. And if you look at what the talk that they had on what's going on in the UK, all those new fungicides that are being developed are being driven by septoria resistance to the older, cheaper fungicides. They're moving into more expensive fungicide products which are no better at controlling the disease. They're purely better because they've got resistance to the old ones. Thank you. Silence.
You wouldn't believe it, but that actually is the end of Steve talking. So, I think we've got time for some questions. So now is your opportunity to ask about all that information that's been put up there. Certainly not the source of some of the slides, but yeah.
It's not mine. It wasn't mine.
Anyone that wants to take this opportunity, golden opportunity, that wants to do something.
Oh, well, let's move on.
Yeah.
Steve Pratt from Andrew. If we've got small seedling plants, like tooth preservative, there's a rain that coming, and we've got infected stuff on the ground, should we be putting the ice block fungicide plant?
If you knew that was your only rain event, then you might get some control. But the problem is getting an economic return out of that is difficult. You haven't got the coolies out, So you really, you're not having a big impact on yield. So that I'd be waiting and still going with, all the evidence is a well-timed 32 spray, which is that third leaf down out, and try to stop, as it elongates, taking infected leaves up the canopy. So I still don't think there's a lot of argument. You can come across some US data where they do get a benefit out of those pre-32 sprays, and they put that around actual increased root growth. So that very early yellow spot, if it's knocking around a lot, you haven't got the carbon inputs going in, you can knock root growth down. We haven't done that work here, but even if you just think about it, in our environment, that's got really different effects, whether that comes through as a yield gain or not. So we've seen that in some years as we run into a tougher finish. Some of that early yellow spot is actually, knocking the plant around and conserving moisture. You can actually be in front in some situations, just the vagary of our system. My advice would probably be to hang off till you get into that 32, and the first rain event after that, I'd go in front of that.
Now, I think this will be your 2 seconds of warning, Richard, before Judge Shepherd gets to you. But Richard Daniel, you've done quite a bit of work in this area. Would you like to provide some comment about your work previously with the yellow spot?
Thank you for the advance warning. Look, back up pretty much what Stephen's saying. Where we were doing that work, if you went with an early spray timing and came back probably 4 weeks later and came back 4 weeks later, I'm sure that's going to give you your best level of disease suppression, because you're putting the lid on the disease 1, 2, 3 times. The issue we're finding is we just weren't getting the economics out of it. So putting yourself on the treadmill in terms of application, I'm sure that's how you get the cleanest crop at the end, but it's all about trying to make it pay as well. And that's where waiting, perhaps if you can, it can be very hard. Wait until you are at that sort of 32 stage where you've got more of the yield generating leaves coming up, and you've got a bit more of an idea of what the season's going to do. I think it's probably a more sensible strategy in most years. And the other thing we see 8 years out of 10 is we have that pressure from tan spot during June and July. We have a 3-week dry period in late July, August, and that's the end of it. It just stops at the base of the plant and doesn't get going again.
I think the key thing to remember with those early sprays is you still get infected off the stubble. Like, it's still an inoculum source. So any lowering of lesions on those leaves with that mid-tillering spray, it really overcome by it getting infected off the stubble. It doesn't just all mature at once, release all their ascospores at once. It happens over the season.
Steve, I think you just made an important point there. You mentioned earlier that people should avoid wheat on wheat. What about wheat stubble that's been there from previous years?
Yeah, that really depends on whether they're matured and released. So in dry years it can carry through one season, but generally, if you get enough moisture, you release them, and that stubble's a lot of data shows that it drops off after that 12 to months or more. But it's really the caveat for that is in a dry year, then it's going to change that situation.
Right, I think we might actually let you off the hook.
Excellent.
Thank you, Steve. Oh, Rachel. You might have gone questions too early. Rachel, do you want to catch up with Steve afterwards? Can I do that? Okay. Or apparently you can